Hello everyone. In this video, we will learn about collision and collision resolution techniques in hashing. Collision is a very common problem in hash tables, and it is important to understand how we handle it. We will also see different techniques like chaining, linear probing, quadratic probing, and double hashing with examples. Let us first understand what collision means. A collision occurs when two or more keys produce the same hash value. This means they try to store data at the same index in the hash table. Since one index cannot store multiple values directly, this situation is called a collision. Collision is very common and cannot be completely avoided in hashing. To handle collisions, we use collision resolution techniques. These techniques help us to store all keys properly, even when collisions occur. Without collision resolution, hashing will not work correctly. There are two main methods used to resolve collisions. The two main collision resolution techniques are, first is open addressing and second is chaining. Let us understand both of them one by one. In open addressing, all keys are stored inside the hash table itself. When a collision happens, instead of using another data structure, we search for another empty slot in the same table. This searching is done using a method called probing. There are three types of probing methods used in open addressing. They are linear probing, quadratic probing, and double hashing. Each method searches for an empty slot in a different way. Now, let us understand chaining. In chaining, each index of the hash table stores a linked list. When multiple keys generate the same hash value, they are stored one after another in a linked list at that index. Here, we do not search for empty slots in the table. Let us understand chaining with an example. Suppose keys 15, 25, and 35 all produce the same hash value, say index 5. Instead of causing a problem, we store all these keys at index 5 using a linked list. So, at index 5, first, 15 is stored, then 25 is linked after 15, then 35 is linked after 25. So it looks like index 5 points to 15, then 25, then 35. This is why it is called chaining, because the values are chained together. Chaining has some advantages. It is simple to implement and there is no table overflow problem. We can store any number of values at one index. But there are also disadvantages. Extra memory is required for linked lists. If the chain becomes long, searching becomes slow because we have to traverse the list. Now let us move to linear probing, which is a type of open addressing. In linear probing, when a collision occurs, we check the next index one by one, sequentially, until an empty slot is found. This method is very simple and easy to understand. Let us understand linear probing with an example. Hash table size is 10. Hash function is h of k equals k mod 10. First key is 23. 23 mod 10 gives 3. So 23 is stored at index 3. Next key is 33. 33 mod 10 is also 3. But index 3 is already occupied by 23. So we move to the next index, which is index 4. Index 4 is empty, so 33 is stored at index 4. Next key is 43. 43 mod 10 again gives 3. Index 3 is full. Index 4 is also full. So we move to index 5, which is empty. So 43 is stored at index 5. This is how linear probing works, checking next index one by one.
The main problem with linear probing is primary clustering. Clustering means many values get grouped together in consecutive slots. Because of this grouping, when a new collision occurs, we may have to check many filled slots. This increases search time and reduces performance. So clustering is bad for efficiency. Quadratic probing is an improvement over linear probing. Here, instead of checking the next index one by one, we increase the gap between probes using square values. This helps in spreading the values more evenly. Suppose a collision occurs at index 3. First, we try 3 plus 1 square, which is 3 plus 1 equals 4. If index 4 is full, then we try 3 plus 2 square, which is 3 plus 4 equals 7. Index 7 is also full, then we try 3 plus 3 square, which is 3 plus 9 equals 12. Since the table size is 10, we take 12 mod 10, which gives 2. So the probing sequence becomes 4, then 7, then 2. This way, quadratic probing jumps further, instead of moving one step at a time. Quadratic probing reduces primary clustering, but it still suffers from secondary clustering. Keys with the same initial hash value follow the same probe sequence. Also, quadratic probing may not visit all table slots. So insertion may fail even if empty slots exist. Double hashing is the best open addressing technique. It uses two different hash functions. The first hash function gives the initial index. The second hash function decides the step size. This gives very good distribution of keys. Let us see an example. First hash function is h1 k is equal to k mod 10. Second hash function is h2 k is equal to 7 minus k mod 7. For key 23, h1 gives index 3. h2 gives step size 5. So probing sequence becomes 3, then 8, then again 3, and so on. Because step size is different for different keys, clustering is minimized. Let us compare all techniques. Chaining requires extra memory but has no clustering. Linear probing causes primary clustering. Quadratic probing reduces primary clustering but has secondary clustering. Double hashing gives the best performance with minimal clustering. So among open addressing methods, double hashing is the best.
Thank you for watching. Don't forget to share and subscribe. It really helps the channel grow and keeps you updated with new content. Your support means a lot. Thanks again.